Hi, everybody. My name is Olivier Beauchesne, and I'm the lead data scientist at MindGeek. This will be probably the plan of the presentation. We're going to go through who is MindGeek, what are our data processing challenges, how we use big data as a service, Lightning, which is our data stack, the goal behind it, the technologies, the architecture, the customization that we did, and also the uses. How do we use it inside MindGeek? So for the ad data processing, the user profiling, anomaly detection, fraud detection, and if we have time, we can finish by a Q&A. Okay, so who is MindGeek? Because I'm pretty sure you guys don't know MindGeek, or maybe just a part of you. So how many people know MindGeek? Okay, well, so half of you. That's good. So MindGeek was founded in 2004. There's more than 1,000 employees. We're specialized in high traffic, high volume website. We're active in content delivery, streaming media, and online advertising. We're behind some of the biggest, most trafficked sites online. We have, as you see, more than 100 million daily visitors, and we push more than 3 billion ads every day. So that's a lot of ads. So those who have not heard about MindGeek, you might know us by our brands. So we are behind Pornhub, YouPorn, Playboy, Brazzers, RedTube, and a lot of other sites. So the data processing challenges that we have, mainly they come from our ad platform called Traffic Junkie. It's a bit like AdSense or AdWords. And our ad platform existed for a number of years. It generates about 10 terabytes of structured data per day, and it cannot go down ever, because when it goes down, well, we lose a lot of money. The problem with Traffic Junkie is that it was built by web developers, which means that they use what they know best, which is a relational database. And it made sense to use it as an administration interface, because you create an ad, you delete an ad, you add some context, you add some targeting, remove some targeting, which makes a lot of sense. For the statistics aggregation, it works until it stops working. So, and like the slide says, throwing money at the problem gets really old really fast, because you get, while it starts to get slow, you get bigger servers, and then you build more features, and then it gets slow. It's slow, so you get bigger servers, you add slaves, you add masters, you add a lot of stuff, and it will always keep getting slower because you always have new features. So a new approach was needed, and we had to support the legacy system while building a new one. And that's really nice about a big company, is that you can take the resources and build something else. In a smaller company, you have to do two things at once, which gets kind of difficult. So the goal is to have big data as a service, which means a bit like software as a service or anything else. We wanted to have a division inside MindGeek that will do the big data service as a service. And MindGeek grew a lot during the past years. What happened is that they bought a lot of companies, a lot, and which means that every company had their stack, which means that you get like a lot of little company inside a big company, which means you have a lot of people doing the same thing. And this means that, well, you have a cost problem at some point. So the goal is to create a company-wide data transport, transformation, aggregation, and storage service, which means you have dedicated experts that they know how to deal with a lot of data. They know how to process everything. They know all the little quirks. When something crashed, they know how to resolve it. I don't. So that's why they're there. Which means that the developers, the data scientists, the business analysts, they can do what they're good at, not playing with servers and doing stuff I don't understand. which means that there's a cost reduction. Because like I said before, when you have a lot of people doing the same thing, well, that's not cost efficient. Also, it raises the bust factor. I don't know if you guys know what the bust factor is, but it means that how many bus accidents your developers can, your team can have. So let's say that you have a bust factor of 1, which means that, well, I lose 1 developer, then, well, we have to shut down the whole thing. So what this means is that you have more and more people that can take care of things, which means that people can go on vacation. And for me, it means no more weekend and weeknight emails. So that's really good because I can have a life. So our task, our stack is called Lightning because cloud. And the goal is to have a real-time, highly available, scalable, end-to-end solution to transport, process, and store and report on any business critical data. That's how we sold it to upper management. So the technology used is things I think you guys all know about. So Kafka, Flume, ZeroMQ, even SCP to transfer files from legacy servers to processing servers. Of course, we have Hadoop under Yarn, Samza, Tez on storage, HDFS. Reporting is done pretty much on Postgres, Hive, and TJ Analytics. TJ Analytics is in-house kind of things like analytics, like Google Analytics. For the management, we use Zookeeper and a bunch of custom software that we wrote to configure and submit jobs. Yeah, okay. So the Samza and Kafka is at the core of the infrastructure. It's stream-based, which means that we get a stream of events, in our case, impression, clicks, joins, any kind of event. And what it means is that we can aggregate stuff and discard a lot of things. Because some of the time, let's say you aggregate, you don't need to keep the events. You can throw them away because you did what you needed to. We use online algorithm, which means that they don't need to be used in a batch way. You don't need to have all the data and have the algorithm go through all the data. The model can build itself as the data comes in. Also, which means that we can have low latency decisions. So in the same session, a user does a couple of, goes to several videos. By the third or second or fourth video, we can act on these first events. So we don't have to wait a day for the data to process, and after that, we'll store the session, and after that, when the person comes back, and then act on it. No, we can do it because it's stream-based. Also, it's scalable. We can spin up instances real fast, which is kind of difficult to do with a regular database. You cannot just like add a new database and then call it a day. No, with that you can add new machines, so you have more processing power, more streaming power, and if something crashes, we can rewind the feed and start over. This is really powerful because let's say we have a module that crashed. We can stop it, fix the bug, rewind the stream, have the offset, and start it again. So, which means that we can start over, which is really cool. It's high availability, which means that if, let's say, we have a crash at some place, your server goes down, we can continue using our system. And the system really fits our problem domain because we have an impression, a lot of impression, we aggregate, we take decision on it, and we throw the data away, which is really cool for ads, but maybe not for genetics or something else. And yeah, disaster recovery. We have multiple data centers, which means that, again, if we lose a data center, we can continue. So that's the high-level schema of our architecture. At first, we have the data source, which is add servers, join servers. We have things about we have billing servers. We have everything that can generate events. It goes to the data transportation layer, which can be SSH or SCP, flu, and 0MQ. We have two kind of processing engine. The first one is called PCAS, which is Processing Cluster as a Service. It's really, really custom, which means that it does one thing and it does it well and it's rock solid. So this is the oldest part of the architecture. The newest one, the Lightning one, which is pretty much Kafka and Samza, is the one that, we get the workers that do aggregation. We're going to go through example later on, so you'll get a better view of that. And it goes to the Hadoop cluster where we can have Hive and other aggregation or decision tasks. We support a lot of data store, Postgres, MySQL, DynamoDB, and the Google stack, so BigQuery and other. And of course, we have our HDFS cluster. Everything for the Google one and the Amazon one goes through something we call the Vortex API, which means that our cloud team can get rid of everything, and then we just I don't have to do anything because my application goes through the API. It's a layer of abstraction, which is a really good thing because it means that I don't need to care about the technology behind. And then behind that, you have the ads, the customer service people, the data scientists, the ProBiller, which is the billing software, Atlas, which is something that is linked to NATS, if you know a bit about affiliate marketing. So that's pretty much it. Okay, so the customization that we did, the first one is a queue monitoring service. So it shows what is happening in the queue right now. So we know that, there's a lot of variance in that queue. It depends on a lot of things, on the targeting and everything. And so we can monitor the health. And we have a lot of statistics that I've blurred out that can permit us to see what's happening right now in all the Kafka topics. Also, we have two other interfaces that will monitor everything that's happening on the Samza cluster. So if cores comes up, cores come down, if we add a server, remove a server, everything's there. We can also send the jar files, which contain the Samza worker, and push it directly on the server and debug and see what's happening in real time. So that's really good to debug and to submit new jobs, because I don't have to go on a machine and I don't know, put my jar on that file. Okay. So I'm going to go more in details on how we use Samza. It's kind of high level still because, there's a lot of details. But everything starts with the delivery servers. The delivery servers, there's a bunch of them that push the HTML of the HTML of the ad, and content delivery network will take care of the content, obviously. So everything is dumped. All the events are dumped in the Kafka topics. And then you have three aggregation tasks. The first one is a simple aggregation that we use for billing and for simple reporting for sales. So that's the first one. And the interface is TJ Analytics, which I have, I think, a couple of screenshots I can show you. And this is used by sales, data science engineers. We also have a module that will write to HDFS and Hive, which we use Hue, or I don't know how to pronounce it, and we mainly use it, the data science team, to data mine, to see what's happening, to see new revenue opportunities. We also have another system, which is I don't know how to classify it, but it does a bit of aggregation and send it to a custom in-memory database. Is a kind of big hash map that means that we can have up to the second impression data, which is really interesting because the customer can just refresh their statistic page and they see the impression as they come in. So I think that's kind of cool. And who use that? Well, the data science team, the sales guys, the engineers, and also the deployment guys, because that I'm sure it doesn't happen to any other company, but you deploy something and it breaks something in prod, and then you want to see if something happens. So you see all the stats going on, and then you can run to the 4th floor saying undeploy, undeploy, undeploy. So that's helpful. Okay, so this is the Hue interface, which I think is really, really useful. So we have all the data that's in the data table. And this example is what we're going to do is we're going to look in the clicks and the impression and see when the country of the ad, the impression, and the click do not match, which means that something funny is going on. So we're doing, if you know SQL, it's really simple. It takes like 10 seconds to write, a bit longer to execute. And then you have an interface that, I mean, you don't even have to put that in Excel or Tableau or whatever. You can just consult it. So if you look at the result, well, you see Opera mini proxy, which means that, well, one of our partner sites is not forwarding the high IP because they, Opera Mini, they proxy the IP, and they proxy the connection. So we get the impressions from the right country, let's say India, and we get the answer, let's say, from USA because they'll have a bunch of server there. So this is one of the results. And we see also data centers, which means that we might have on that site, on that system, a bug problem that we have to take care of. Okay, so this is an even zoomed in view of another processing system. So we have the delivery servers that dump all the events into the Kafka topic. And on Samza, you have 2 processes mainly that we use. The first one is a process function, which is called every time you have an event. So you have an impression, an event coming in, it gets called, and you decide what to do. In that case, we filter. We have some stuff that we don't care about, so we just throw them out, and we aggregate what we want to aggregate. The window function, it's called every minute, and we'll do a kind of aggregation so we have less data to work with. It dumps into a Kafka output topic, and after that, well, it goes to a persistent layer, which is called, in that case, every 15 minutes to a data mart. And then from the data mart, the business analyst, us, everybody can query. Same thing with the interface. So this is TG Analytics. I know it's a bit, well, everything's blurred because it's business data. So, but mainly it's a lot like analytics. So you're able to see what are the ad pattern, the CPM, the joins, the clicks, everything. And the one on the left, the one on the left is competitivity. So we know that there's a lot of competition on that zone in that country, or there's not a lot. If there's not a lot, when it's red, the sales analyst can then call big customers and say, you should bid there. Your campaigns usually really do well in that zone, in that country, and there's that opportunity where you're not going to pay a lot for that campaign. So it's a really useful tool. User profiling. User profiling, again, the same thing. Start with the delivery server. Everything gets dumped in the Kafka topic. And then we have a process function, which is called, again, every event. We hash the GUID so to partition it better, so we have a better distribution. And the GUID is a global unique user for every user that goes on our network. And we use the content-based profiling, which is like our secret sauce that makes sure that what we do is that we have, let's say, a user, and we have all his old actions, and then we can, after that, say, well, he likes this kind of content, so we're going to show ads related to that content. Everything after is dumped into a Kafka topic, which is dumped to a fast storage system, which after that is queried by a user profile API. So when the delivery server recognizes a user, they can query the user profile API, get their profile, and say, well, okay, we're going to show them this ad. Okay, and anomaly detection. This is something else which is really important because it means that when something goes down, something goes up, we want to know about it because it's a really big system and a lot of people are working on it and you cannot keep an eye on everything. So everything again starts from delivery servers, dump into a Kafka topic. And what we do here is an aggregation on certain parameters that we want to know about. Obviously the time, the spot, it could be everything, keywords, whatever you want. And it builds a template so it knows what normal means. So in a given, we'll have an example, but for a given zone in a given country, this is what normal looks like because it varies during the day and even during the week. It gets dumped into a template storage, and there's the correlator, which will look at the current data and historical data, and when something is wrong, it's going to trigger an alert and store it in an interface, in a DB, which the BI interface can be queried to know what's happening. Usually the people using it is the salespeople because they are paid by commission. So they want to know what's happening in the system. They look at it every morning to see if something has happened during the night. So that's pretty much the interface. So you have the blue line, which is what's normal, and you have confidence interval where everything be inside of it is pretty much normal. And you have the red line, which is the current date and what's happening. And we see that, well, it's a bit outside. It's not the end of the world. So usually when something like that happens, we look a bit to make sure that there's nothing, and then we move on because, again, it's not the end of the world. The last example of how we use the Lightning system is the fraud detection system. So what happens is, of all the sites I showed you earlier, they were all tube sites. Tube sites, they don't really have memberships and you don't pay an amount per month, so everybody can go on them. The pay sites are another story. You have to pay, let's say 30, 60, even $100 a month to have access to it, which means that a lot of people, well, not a lot, but a good quantity of people will share the logins. So we have to stay on top of that. So we have pixels and JavaScript, which will, on the logging pages and other pages that will send event to an event aggregator, which will dump it into Flume, which will dump again into a Kafka topic. And then you'll have a Samza worker using historical information, using other parameters to see, okay, do I know that user? And where did he log from? And what is his pattern and everything? And a confidence score will be calculated, dumped into analyst result DB, which for that system, we use DynamoDB. And later on, there's an API which queries that result, DB, and the billing software will communicate with the API, which again, the API is a really good idea because we can, I don't know, if tomorrow a better technology comes around, we can just dump everything else and the billing software will still work. So that's, okay, so this is the interface. So it's really simple, but highly powerful. So you have the ID of the event, you have the customer ID that you cannot see, and you have also all the events that happened and where the user logged in. So in that case, it's a bit small, but you have, I can't read it, but it's cities all over the world, and they trying to access browsers. So this system will dump it in the database, which can be queried like this, or the billing system get an alert, and the guys in customer service can block the account, talk to the user, or whatever they want to do, because now they know that this account has a high percentage probability of being hacked, or just that they share the password, or they use a fraudulent credit card and they don't care about it. But the system also needs to be powerful enough to know that if you're a user and you're in Canada, but you go overseas and then you open the browsers in your hotel room, then it won't block it because you're going to be mad. So it's the same thing when you go back. So it has to be powerful enough to detect these case. So as always, thank you for your time. And if you guys have any questions, how is the data stored in the fraud detection knowledge base?
Like XML.
Oh no, it's tables. I think it's tables. I think yeah, you built it, Jay. How did you build it? But I think it's a Postgres database.
Yeah, so the first type of knowledge base is simply stored in Postgres. That one is built offline, and then the other is stored, called a real knowledge base, which is stored in DynamoDB. None of them is XML. So for the reason we store them in DynamoDB is we want to have extremely low latency, so that it's almost instantly you can get the results.
So you get information.
Yes. So the stuff in the DynamoDB we call the knowledge base. The stuff or the stuff in the DynamoDB we call the lookup knowledge base. And then the records stored in Postgres we call raw knowledge base. It's raw, so it's built offline. And the lookup database is designed to be looked up online. It's that. Did I answer your question?
Yeah, the question was, what is the fraud algorithm that we use? And it's really, I can't really talk about them because, well, you know how it is. When you know about the algorithm, you know how to go around it. And it's a kind of a cat and mouse thing, so yeah. So that's part of the NDA. Okay, the question is, what is the back end of the data mart? It's really simple. The answer is boring. It's Postgres. So it's a really, really big Postgres server. So that's pretty much it. We don't use any fancy data mart system. Clusters of servers, I think, yeah, a bunch of slaves, really big servers, yeah. So we're throwing money at the problem. That's pretty much it. Yeah, so the question is how do we manage the use allocation problem? As you said, we fight for it. So that's pretty much it. And we have a cluster, and yeah, that happened. I go see Ben who created the Lightning system. And I say, Ben, I'm trying to run a query, and like, yeah, somebody's hogging all the power. Can I have some? And then that's pretty much it. So, and after that, I go see my boss, and I say, I would like more servers, please. The question is, how do we deal with ads that, let's say, can be misleading or something? Okay. Every ad that goes through our system we have people in sales that go through the ad, through the landing page, and make sure everything is legit. Of course, some of the people, what they will do is that they'll change the landing page, they'll change the content. We use also the service Risk IQ that will scan all landing page, all content, to make sure that there's not any malware, but it's the internet. There's another part of it, which we resell space. And this is a part that we have contracts with other big companies that do that, like it's Exoclick, Respo, I don't remember all the names because it's more of the business side of it. And they, by the contract, should do that. But like everything, nothing is 100%, and it can fall through. Of course, we're more looked at because we're in a market that is more taboo. So people will complain less about it, and we're under pressure to fix this stuff. But like everything, it's not 100%. A join is that, let's say that you're on Pornhub, you look at a video, you have impressions, you have ads. you click on it. So after the impression, you have the click. And when you go to the landing page, you look at the let's say it's an ad for a gallery or an ad for another site. You go through the galleries and you say, well, this seems like a swell site. I'm gonna buy a subscription. And you put your credit card number to get the email that, okay, you're a proud member of Brazzers, and this is a join. So it's a funnel. So it's the end result, what we want to optimize for. So it's at the end of the day, it's the CPA. So it's the cost per acquisition. So that's how you optimize for this system. Okay, what are we using for geolocalization? We're using MaxMind, which what I think it's like a standard. There's also, I think, digital, no. There's another one that we don't really use, but it's MaxMind, and it uses the IP address, and we have the location at the city level usually. The question is, why did we choose our current stack? I can give you the reason why we use another stack is because before we have ETLs and cron jobs and really, really ugly stuff, and we wanted to move in the modern world, so that's why we went with big data. Ben can answer why, how did we choose this stack?
Before we select any the technology, we always do the benchmark first. For example, when we select the Samza, why not Storm? Why not Arca? Or the other framework? The reason is we try to do the benchmark. We do a lot of research because each technology, they have positive, they have negative. So we want the solution can fit our business requirement. So we do the benchmark, also check performance, then make the final decision. Most Samza we pick up Samza because of Kafka. Kafka and Samza come from the same company, from LinkedIn after they shipped to the Apache. And they all was implemented by Scala. Samza, the Kafka, when we start the Kafka, we talk about the offset. So the user, they need to handle offset by themselves. They can use Zookeeper, they can use the other way. They can input the offset to any database or anywhere, but we don't want the developer to go details. So if you start using Samza, you can ignore all the details. You can just go there, consume any data you want, and you never worry about if any data is missing or any data is processed duplicate. So we found that the benefit, so we chose it. As same others, why we took something like HDFS, why we took about the Hive, because we found they can fit our needs. Okay, this is the answer you like it? Yeah. Good, cool, thank you.
Thank you, Ben.
Thank you.
How do we manage single site sign-on? The answer is I don't know. This is not my department. That's the problem of a big company, is that I don't know what the guys in pay sites for the single sign-on do. Is it available? Do you know?
On tubes, no. On pay sites, yes. It's because we take over the login.
Okay. Okay. The answer is not on tubes, like Tube8, Pornhub, YouPorn, and everything. They're all like separate services, but on pay sites they have single sign-on, and it's because we took over it. One reason is the fraud detection. I think we're good. Oh yeah, we're hiring. On engage. Merci beaucoup.